Okay, class, this is a topic in machine design. So, this presentation covers the fundamentals of this subject. So, the first topic, of course, is the simple stresses. So, by the way, let us first define what is stress. Okay, stress is the load applied per unit area of the surface the load is applied. Okay. For tensile stress, we have here an illustration or a picture showing the application of the load. So we will notice that the load is separating on both ends. So the tendency of the material under this load is to have a certain elongation, or there is a minimal or elongation that will happen to the material. So because the fiber of this material is stretched to a certain level, so knowing that the formula for stress is equals to F over A. So take note that this is class tensile stress. This is designated with sigma T. Sigma T. So T, or the subscript T, represents the tensile stress or load. Okay? So that is equals to F over A, or knowing that the cross-section of the specimen here is circular. So the area is equivalent to pi, the square of the diameter of the specimen divided by 4, and then substituting it to the equation, sigma T is equals to 4F over pi d square. Okay? So that is about tensile stress. Okay? So where F now is of course the applied load. So take note that the unit here is sometimes in Newton, sometimes in pound force, and sometimes in kilogram force. So for the area or the cross-sectional area, that is in millimeter square, inch square, or the centimeter square. And the original length is of course in millimeter, in meter maybe, in inches, or in centimeter. Okay, same as with the diameter of the specimen. Okay, so we have here an example. So in order to determine a certain parameter, okay, so let us consider this example. Determine the outside diameter of a hollow steel tube that will carry a tensile load of 500 kilonewton at a stress of 140 megapascal. So assume the wall thickness to be 1/10 of the outside diameter. Okay, so take note, class. Since the given here is 500 in terms of kilonewton and the stress is in megapascal, we have to change this 500 to newton. Okay, so 500 kilonewton, making it kilonewton, that is 500,000. Okay, so take note that automatically the thickness of the material here is in millimeter. Okay, so let us now consider, take note that the required of the problem is the diameter of the hollow tube. Okay, so knowing that the diameter of that tube is equal to the 2 multiplied by the thickness, okay, plus the inside diameter of the tube. Take note, the outside diameter of the tube is equals to 2 multiplied by the thickness plus the inside diameter. Okay, or getting the small diameter or the inside diameter, that is equals to D minus 2 multiplied by the thickness. Okay, so substituting now the value of the thickness is equals to 1 over 10 of the diameter or the bigger diameter or the outside diameter. So substituting it from the above equation, that is now d equals to d minus 1 over 5 times d. Or simply, the small diameter is equals to 4 over 5 multiplied by the bigger diameter or the outside diameter of the tube. Knowing also that the area is equal to pi over 4 multiplied by the square of the diameter minus the inside diameter, because we are just only looking at the resisting area to the force. Okay? So, this is for hollow circular section. Okay? So, next, substituting it now, pi over 4, and then multiplied by the substituting the value of the small diameter, which is equals to 4 over 5 square d square. And then, combining now the value of d, so that is 16 over 25 or d square minus 16 over 25 d square, getting the common denominator of 25. 25d minus 16d is 9d square over 25 multiplied by pi over 4. Okay? So, substituting from the or knowing the formula for the tensile stress, sigma t is equals to F over A. And then, substituting it to the equation, the square of the diameter is equals to 140 raised to 1 or, yes, so, multiplied by 500,000 over 5 times 9 over 100. Therefore, the value now of the diameter is equal to 113 millimeter. Okay, class? So, very easy. So, another example we have here. A steel tie rod on a bridge must to withstand a pull of 500 pounds. So, take note, class, that the given here is in English. The previous example is in SI units. Okay? So, find the diameter of the rod assuming a factor of safety of 5 and an ultimate strength of 64,000 pound per square inch. Okay? So, solving now, the sigma t or the tensile stress equals to F over A is equals to the ultimate strength of the material divided by the factor of safety. Substituting the values, the ultimate strength of the material is 64,000 divided by the factor of safety of 5 is equals to 5,000 over pi over 4 multiplied by the square of the diameter. So, therefore, now, the value of D is equals to 0.71 inch. Okay? So, okay, class. Thank you very much. That ends now my presentation. Okay.